The dream of discovering alien life amidst distant stars has always lingering curiosity for us as humans, and it seems that new mysteries continue to unfold as more powerful tools are being used to answer the questions of the universe. This is a timely development, especially when potential evidence of extraterrestrial signals from the closest star to Earth has recently been uncovered. Keep watching until the end of this video as we zoom in on the James Webb Space Telescope discoveries. Welcome to Space Infinity. James Webb Space Telescope. The largest optical telescope in space, the James Webb Space Telescope has been in operation for almost a year and has already provided us with plenty of mind-blowing data and images that have pushed our scope of understanding of deep space even further. The most expensive and advanced tool in humanity's arsenal, it is packed with powerful instruments that detect in high resolution and sensitivity, allowing objects to be 6 times more observable than its predecessor, the Hubble telescope. The James Webb Space Telescope, or jwst, has the ability to collect data and observe in a lower frequency range, from long wavelength visible light through mid-infrared, allowing it to look farther into the darker reaches of space. It has a primary mirror of 18 hexagonal mirror segments made of gold-plated beryllium, which provides much better insight, able to support further investigations across fields of astronomy and cosmology, with the main objectives of observing the first stars in the galaxy, the early formation of these galaxies, and is also our primary tool in the detailed search of potentially habitable exoplanets in nearby systems. The world's most powerful telescope, which is floating roughly 1 million miles away from Earth, is our greatest tool at finding these alien worlds, able to analyze these exoplanets' atmospheres in order to assess whether they have the ability to support life. And despite being originally intended to mainly scan the outer reaches of the cosmos, the jwst is now expected to break new ground in the search and exploration of exoplanets. It's important to note that back in the 1970s, no one even knew that exoplanets existed. One of the early motivations of building the Webb Space Telescope was to launch a telescope that would be powerful enough to detect the earliest stars and galaxies. And as we've come to understand the continuing concept that the universe is expanding, we've also gone to understand that this expansion reddens light as it travels across space, which is why it was imperative to build a new eye into the cosmos with the ability to observe in the infrared spectrum. This detailed sensitivity also allows valuable measurements of atmospheric properties of these exoplanets, allowing us a peek into that planet's composition and actual on-planet situation. And now, as the jwst continues on its mission, it has become one of the most important instruments to explore alien worlds. This is exactly the tool we need, particularly to unravel one of the latest mysteries of deep space, the radio blip. On December 18, 2020, a report was published in The Guardian that a mysterious radio signal was detected at 982.002 MHz, analyzed by the Breakthrough Listen project from the Parkes telescope in Australia. The unknown signal seemed to be coming from the nearest star to our Sun, Proxima Centauri, a star too dim to see from Earth with the naked eye at about 4.246 light-years away. This particular star is host to an Earth-sized planet, Proxima b, located within its habitable zone where liquid water present could allow life to prosper. While there hasn't been any scientific paper detailing Proxima b's potential, this radio signal, which had come from this direction, is raising questions on whether it could be coming from this exoplanet. Astronomers have been keen to verify that the signal cannot originate from radio interference on Earth or some natural emission mechanism, so all eyes and ears are in Proxima b's direction. The detected signal is most curious in that it occupies a very narrow band of the radio spectrum, 982 MHz, a region that is mostly bereft of transmissions from human-made satellites and spacecraft. According to researchers, perhaps this could be some yet unknown exotic quirk of plasma physics that could be a natural explanation for these concentrated radio waves. But for the moment, the only source they could determine is that it is technological in nature. This makes the detection a primary point of interest for the SETI, or the Search for Extraterrestrial Intelligence. The initial detection of the mysterious radio signal was made through the $100 million project called Breakthrough Listen, which began in 2015 with the goal of observing radio telescopes around the world to search the skies for evidence of technological civilizations. So far, no hard, conclusive evidence have yet to be found, with any potential signals received from space being always ruled out as originating from satellites orbiting Earth or other human-caused interference instead. According to SETI astronomer from Penn State University, Jason Wright, if you see such a signal and it's not coming from the surface of the Earth, you know you have detected extraterrestrial technology. Unfortunately, humans have launched a lot of extraterrestrial technology. As for this intriguing signal, it was noticed when a team had been studying Proxima Centauri for signs of flares coming from its red dwarf star, in part of efforts to understand how such flares were affecting Proxima's planets. The system is known to host at least 2 habitable worlds. The first, Proxima b, was discovered in 2016 and is about 1.2 times the size of our own Earth with an 11-day orbit. Another planet, the roughly 7 times the Earth's mass Proxima c, was discovered in 2019 with a frigid 5.2-year orbit. These exoplanets reside in the star's habitable zone, a sector in which liquid water could exist within the rocky planet's surface. In June 2020, researchers had stumbled upon a curious narrowband emission, hidden in plain view in the Proxima Centauri observations. The signal, now known as BLC-1 for Breakthrough Listen Candidate 1, has piqued researchers' interest. The signal, mainly received as a one-note tone, has no additional features that can be discernible at this point. However, the signal does contain drifts, with the tone appearing to be changing very slightly in frequency. This could be due to the motion of our planet, or of a moving extraterrestrial source such as a transmitter on the surface of one of these Proxima Centauri worlds. This drift is also a mystery, since it is the opposite of a signal one would expect originating from our Sun's nearest star. JWST focus. As we try to uncover the mystery of Proxima Centauri, the James Webb Space Telescope could prove vital to making any new discovery in the region. While the signal name BLC-1 is still being analyzed to ensure that it isn't simply an echo of our own human civilization reverberating through space, the JWST could focus its sights on the proximity of Proxima Centauri to see if a civilization does exist in that region of space. From space, the most obvious sign of civilization on Earth is the night-side glow from cities emitting light that's being thrown out into the cosmos. We may be able to see the light of a distant world, or observe traces of atmospheric pollution left from nuclear conflict if that situation may have occurred. These indications of technology could provide the evidence we've all been looking for. However, these traces of technology could also be caused by natural phenomenon, such as orbiting debris or impact from a comet. We are now using the James Webb Space Telescope to try and observe artificial illumination, assuming that the night side of the planet would be completely dark, devoid of artificial illumination. The type of light used by a hypothetical civilization on Proxima b would be assumed to read as similar to LEDs here on Earth, which have a distinct artificial spectrum that can be detected. If the artificial illumination on Proxima b reaches at least 5% of the natural dayside illumination, the JWST would be able to detect this artificial light with as much certainty as 85%. While 5% illumination may not sound like much, it's still a lot of light considering that Proxima Centauri's sun is 20,000 times dimmer compared to our own sun. If a hypothetical civilization in Proxima b hosts a civilization that's as technologically savvy as us, JWST would still need their artificial lights to be 500 times brighter in order to detect it. Proxima b is also 20 times closer to its star than the Earth is from the Sun, making it tidally locked together, with Proxima b facing the star with a permanent dayside. If there is a civilization on that exoplanet, it would likely be covering the permanent dayside with photovoltaic cells to transfer electricity into heat and allow it to illuminate its night side. One thing's for sure, this spectral edge can be more observable hopefully by JWST or by more powerful telescopes in the near future, allowing us to see more of that which might be hypothetically hidden. We'll have to keep our eyes and telescopes focused on Proxima Centauri to understand this possibility even more. So what do you think about the James Webb Space Telescope and its discoveries? Let us know in the comments below. Space Infinity will continue to deliver the latest news on the vast oceans of space and all its new discoveries. So tap that like button and subscribe. We'll see you in the next one.